Hello everyone, my name is Chukwemeka Johnson. I'm a risk manager and a software developer. I just concluded the development of an expected credit risk model using Python programming language. The objective of the model is to compute IFRS 9 impairments by recognizing lifetime expected credit losses for financial instruments for which there has been a significant increase in credit risk since initial recognition. Where there is no significant increase in credit risk, the model will compute an amount equal to 12 months expected credit losses. Now, for the model to uh, initiate, all it requires is your source of database, which could be the core banking application of the financial institution, or an Oracle database, an SQL, an Excel, or a CSV file. Now, for this demonstration, I'm using a CSV file, which comprises of the risk asset portfolio of any financial institution and a schedule of microeconomic variables. Now we'll go straight to initiate the application by pressing any key to continue. Once that is done, the computation starts. The first thing it does is to forecast PDs using matrix multiplication. It computes the matrix migration of risk groups for the PDs for each sector. As you can see, the first sector he has picked is the general sector. At this point, the model stops and prompts you to impute your first microeconomic variable. But before that, let's look at some of the computation that has already taken place. Now, the result of the migration will give you your conditional PD, which you will now use to perform a correlation analysis to determine if there's a correlation, a relationship between the microeconomic variables and your monthly PDs. All right. So this is the result of the correlation analysis that you are seeing on the screen. In this demonstration, there is no correlation. There's no strong correlation between the monthly PDs and the macroeconomic variables. But we'll go ahead and choose, for the sake of demonstration, choose any random microeconomic variable. Actually, two will require two microeconomic variables. So the first one, I will go ahead and choose inflation rate, and choose another one, money supply. Now the modeling continues to the next sector and goes on and on to until it gets to the end of your portfolio. Now the result of um, your output for this application is saved in a CSV file in your computer. All right, we'll look at that in a while, but let's also go back again and look at some of the computation that has also taken place. Um, Once you've imputed the two microeconomic variables, the system will try to determine the micro coefficient using logistic regression. Now, in doing that, what it does is to uh, perform a maximum likelihood estimation and also forecast um, the microeconomic variables. All right. So, in the result, the output of that will be the point in time PD. Now, but let's first of all look at some of the results. You see that the optimization process was successful, and the log likelihood has been maximized by the application, right, which was now used to um, determine the point in time PD. Now, in order to also have a robust application, we decided to look at not just the baseline forecast, where, forecast of the macroeconomic variable. We also look at the worst case and the base case forecast of the macroeconomic variables and see the result of our point in time PD. All right. So that is the result you're seeing on the screen. So this result will now be used to determine the unconditional PDs rather. Will now be used to determine the unconditional PDs for risk group 1 and 2. So that is our objective for the PD modeling, and that comes to the conclusion of the PD modeling. It will give you the results, the unconditional PDs for all the risk groups that you have imputed. All right. So it goes to the next sector and goes on and on until it gets to the, the last sector in your portfolio. In the next video, you'll see how the application computes the LGD modeling and also the EAD modeling to arrive at our ECL figures. Thank you so much.